Oh, welcome guys. So in this video, we are trying to prove the people want like to ask about the Cauchy Riemann equations. So the Cauchy Riemann in polar coordinate form. Okay, so the proof will be very so f of z. Usually we will write f is u plus iv, right? So the Cauchy Riemann in the standard textbook is this form, right? So and then we want to prove that the Cauchy Riemann in a polar coordinate. So f of z now is basically the large R exponential I large theta. Okay, and the proof is basically really simple. We just follow the delta f delta z. So by the way, this f, right? So now this f looks like this delta R delta I theta. So it's basically the standard Leibniz rule. And what is this delta z, right? Z is just small r small I theta. So we guys just copy theta, right? Oh, I should use this. So this is this stupid result. It's stupid. It's just the large theta symbol. Okay, I think everyone knows about this. Okay, so this is our starting point. Okay, so we want to prove that we want to relate this, have some relation with respect to this r and large theta, just as what we did for this. Okay, so the proof. So the proof is very simple. So proof. So the first fact is that we can have different approach, right? So we can approach delta r to be 0 and the delta theta to be to exactly 0. So we just first set delta theta to be 0 and change with respect to the radical directions, right? So we have this plus r over r. Sorry. So delta theta is 0, right? So this term is 0. So we get the, let's say r I, right? So delta theta divided by delta r is just partial theta partial r. Okay, so I change this to be partial because now the direction is fixed. Partial. So and times this large exponential, which I don't. This large delta minus small delta, and this term will cancel, right? Because everything is the same. In the second, we can view delta r to be 0, and only change the tangential directions of this delta theta. Okay, so it's very simple that delta r is 0. So the first term is just the first term is large r delta r minus delta theta, so it's partial theta r, and 1 over ICO in the denominator, and then there's an r here, right? Small r here, that at least one, and at least and the second term is just r over r, and I cancel, and I cancel, right? So I cancel, and the partial large theta partial small theta, and times this times the same factor, and these terms should be the same. These two terms should be the same. Okay. Okay, and the real equals to imaginary. Okay, so let's say check for the real part. So the real, the first equation is this. The real, okay. Okay, so this is the first polar coordinate, Cauchy Riemann. Okay, so this is the correct form, and the second one is these two terms. So it's r partial theta partial r equals to partial r partial theta r, right? But there should be a negative sign here. So combine all of it, what we can change into partial r partial theta 1 over r equals to minus I change this into this. So this is one of small r and a large r. Okay. Nice. So this just shuffle the equation. Okay, nothing special. So this one and this one are the Cauchy Riemann in polar coordinate. Okay. So subscribe to my channel if you want to see my proofs, the advanced math, and I will see you guys in the next videos.